Welcome to our review on energy and efficiency. So the first thing we need to know are a few key terms and what they mean. So two that are endlessly mixed up and used as interchangeable when actually they're completely different things are weight and mass. So whenever we're talking about the weight, we are talking about the force of gravity acting on an object. So will be measured in newtons. If we're talking about the mass of an object, then we're talking about the amount of material that something is made from, and that will be measured in kilograms. The last thing we need to know is what 1 joule actually is, because we've talked about joules quite a lot, but we haven't actually said what 1 joule is. So 1 joule is the energy needed to lift a weight of 1 newton by a height of 1 meter. When we come to think about efficiency, we need to know about two kinds of energy. The input energy, which is the energy we supply to our device, and the output energy, which is the energy that's transferred by the device. If we think back to what we've looked at previously, we know that energy can't be created or destroyed. So that tells us that whatever the input energy is, must equal the useful output energy plus the wasted output energy. So whatever we put in must come out. The next equation we need to know is the one for efficiency. So if you're asked to calculate the efficiency of an object, then what you need to do is the useful output energy divided by the total input energy and then times that by 100 to give it as a percentage. Now, you don't always have to give it as a percentage, you can give it as a decimal, but just double check what the question says before writing your answer. An example of the kind of question you could be asked is here. An electric motor is used to raise an object. The object's gravitational potential energy store increases by 50 joules when the motor is supplied with 200 joules of energy by an electric current. Calculate the percentage efficiency of the motor. First thing we need to do is, as we read the question, highlight, circle or underline all of that important information that we need. Second thing to do is to write down the actual equation we're going to use. So efficiency is useful output energy divided by the total input energy times 100. And then we can substitute in the values from our question. So as we can see, the useful output energy, so the energy that's going into the gravitational potential store, is 50. And it's been supplied with 200. So 50 divided by 200 times by 100 gives us 25% as the answer. There is a very handy little check you can do here, because when you're calculating the percentage efficiency of an object, it cannot be over 100% efficient. Because if it was over 100% efficient, then you'd be getting more energy out of a machine than you've put into it, and that's impossible. So if you've done your calculation and you end up with 136%, you've got the numbers the wrong way around. So flip them, times by 100, and you'll get the right answer. Hopefully at the end of this video we can say what wasted and useful energy are. We can recall the equation for energy efficiency and use it to carry out those calculations.